Hello, everybody, and welcome to Pocket Coach. I have a really exciting experiment for today. It's one of my absolute favorite ones. Definitely my favorite one in the testing world. Definitely my favorite one in the advanced experiments, but it's close anyway. But it's huge. It's called defect prevention. So first, let me start my 5-minute timer. And I have to tell you, there are two other videos that are really helpful when watching this that I have on my old channel. So I'm going to move them over to this channel and publish them so you can see them. One of them is called Mercury in the Lake, and it helps you understand what defect density is all about, which I'm going to talk about on the edge today. That tells you what it really is. And the other one is You Didn't Find That in Test, and it explains why all tests is a subset of tests and just how bad a subset it really is. So I'll put those two videos out in the next 2 weeks. But for now, let's take a look at defect prevention. So what is the problem we're trying to solve with defect prevention? When we test our code, it's always a small subset of all the possible paths. So that video will show you why. Therefore, for every bug we find, there are a way more bugs that we didn't find. So, for example, if we realize we test 10% of all the possible paths to our code, and that's not super unlikely if you watch another video, and we find 10 defects in that 10%, well, then we can assume that in that other 90%, there's an equal density, and that's the other video, which would be 90 defects. So that means that there are, for every 10 we find, there's 90 we don't, right? That's massive. And so they're going to be found in production. We don't want that. So the hypothesis here is if we study patterns and defects, we can come up with techniques to prevent or eliminate them. So we not only eliminate the 10 bugs that they would have found, we eliminate the 90 that they wouldn't have ever found because we never created them in the first place. That feels like you're going to time traveling, but we're talking for the future. So what's happening here is today, most of my clients use test as a bug hunt. They find it, they fix it. They find it, they fix it. And that's what they think test is. And that couldn't be more wrong. Yeah, if you find a bug, you should fix a bug, but that's not the job. The job is to prevent that kind of bug from ever happening again. And so that's what defect prevention is about, is shifting the mindset from find and fix to find and prevent. Okay. This one's going to take a while, maybe 12 sprints to really start to see the impact, but really after 2 sprints, you ought to start to see the patterns. Typical outcomes, you should see a definite decrease in the number of defects that are found in production because that's the 90. During test, you will find a drop in a category, but because testers should be testing always new ways, you may not see an overall drop in defects there, just defects of the category you've targeted. Skill growth criteria. In other words, what do you got to do? So number one, you have to harvest real defects. Number two, you have to have listed them out, studied them, and found categories throughout those defects. Often categories you would never have thought of until you see them all kind of in one pile. You created a pattern to eliminate your worst category. So that means you got to do like a Pareto to find your worst category, and then how do you prevent that category from ever happening again, right? And then you repeat for your next highest category over time. And then you also have to see the category either completely disappear or at least drop during subsequent test cycles. So like as an example, let's say that uninitialized variables was your biggest category and you create a little automation that walks the code and finds them all and repairs them. And now you never find an uninitialized variable again. That would be a defect prevention experiment. Okay, so that is the experiment. We already used up 3.5 minutes of my box. So this is the little practice that I have. Number one, choose what you're going to look at the quality of: a product, an application, a user interface, a piece of an application, and then get a list of actual defects that tie to that scope. Okay. Then add those defects to some sort of tracker. And I have a template I'll show you in the second 5 minutes. And then look at them and find categories. Now, number 5 says consider stock categories as well. There are categories we use again and again. Those are secondly good, but the most important ones are the ones that you discover by studying for the patterns. Then you write a defect prevention report explaining what you found. You collaborate them with everybody else, product owners, scrum masters, requirement folk, dev test, it's anybody, right? You collaborate with the people who actually have to change their behaviors for those categories to be eliminated. And you create action plans, how they're going to do that. Then next period, you test for that same category, just like I did for the uninitialized variables, and you show, whoa, they're gone or dramatically reduced. So those 8 steps are the overall process. I have some details below here, on how to do those steps. But the next asset. So we're down to 22 seconds. The last two things I'm going to show you, and I'll show you them in the second 5 minutes, is a defect prevention Excel sheet and the Pareto charts that we came up with the graphs to help us find the worst category. And that's about it. So that's what we'll do in the second 5 minutes. All right, so I'm going to go ahead and just reset this now. We're into the second 5 minutes, so if you stuck around, let's see what we got. So next up is this tracker. So first off, the tracker can have stock categories. That's what these columns are. They're whatever categories you want, right? These are the ones that we used in this experiment. But that's not the exciting one, right? What we really need to do is add the column K, right? And the new column. And it's, hey, I noticed that a lot of the categories share this characteristic. That's where the dynamite really ends up being, okay? So I wish I had an example, but when I do this with my clients, they don't want to share because they think it's a competitive advantage, right? But once you have enough of these in here, now you can start to create distribution graphs. So you can see here defects by severity, by product area, right? So let's say that Sev2 is your biggest category more than any other. You're like, why do we have so many Sev2s? Is there something we can change, right? That one's less likely. Here by product area. So you can see here account management is the big daddy, but a shopping cart was the big daddy. Then it's like, okay, whatever we decide to fix, it needs to be in that part of the product. So this can tell you where to target your improvements. By requirements type. So this by requirements type. Oh, so let me show you the last asset here, which is oops, we already saw that one. It's the definitions of all those things. So I don't want to go through all these definitions here, but I want to show you the style. So first off, we have defect categories, and then we have fix categories. So not only do we look at the patterns of the defects, when the defects get fixed, we look at the categories of the fixes and often can find amazing things there as well. So notice that for each of these, we talk about why did we capture this? So make sure you do that. Every one of your columns takes time. So what do you expect that column to give you? So as we said here, the defects by product area will give us what area to focus our improvement initiatives around in. So it's worth it, right? So I came here because we said defects by requirement type. I don't have really good definitions here, but it allows us to improve how we work on requirements, right? If the biggest problem is usability, then that's where we need to start improving. If the biggest problem is incorrect, well, that's a very different strategy, right? So what kind of behavior changes are we going to need? Code, build, environment. Where did the final change actually happen? So notice these first three are about where the defect happened. All the rest of these are about where the fix happened. And so we need to look at the source, the age, the team, etc. Right? So if we look, defects by requirement type will tell us what behavior changes can be quite different depending. Target fixed, right? Where did the fix end up happening? And so that tells us where we need to do our plays. The source, was it built by this team? Was it reused from an internal? Was it reused from external? Was it outsourced or was it ported? If we find that outsourcing is our biggest source of defects, then our play is going to be quite different than if it's built by this team, right? So again, these categories will give us ideas of where to improve. Age, right? The older the defect. So wow, most of our defects is in really old stuff. So what should we do? Versus most of our defects are in the new stuff. So the old stuff is actually pretty good. Well, that's very interesting, right? What should we do? And then here by team. And so if you realize the retro crushers, now a lot of times you can't tell what team built something. That's okay. You put undeterminable, not determinable, whatever, that's fine. But often you can determine it. And especially if you look at the fix, when you look at the fix, the team that says we'll fix it, especially if you have a product focus, should be the team that owns that product. And so it's still worth it to track the fix team. And then you can say, well, the biggest fix team we have is the retro crushers, and they're fixing their own products. So we maybe need some improvements in the retro crushers, right? This only works if you have a product mindset where people, do their own DevOps, they do their own fixes and whatnot. So there you have it. This is defect prevention. Again, what's missing from this set is that discovered category, the beautiful mind, where you see all of these different defects and start to see patterns and say, oh my gosh, I see something here. And if we did it, we would eliminate our biggest category. So that's what's exciting about this. You look for your biggest category, you come up with a plan to eliminate that category, and you prevent that kind of defect from ever being created again. And in the next round of testing, you test for that category to prove if your innovation has actually worked. So my absolute favorite test practice, defect prevention. I hope that you guys found this one exciting as I do. So let me stop the timer here. My name is Anthony Crane with Pocket Coach, and I hope you gain value from this one because I was really excited to share it. All right, bye everybody.